mixed combination. We are studying grouping of cells, and here we come across mixed combination, which means series and parallel, both the options will be open for us. But the number of cells in one row or the number of rows will be decided depending on the situation as and when required. You see, here we have drawn a circuit in which in one row we are having 4 cells, and overall we are having 3 rows. But let's suppose there are n cells in one row, n cells, and there are m such rows. Such rows means simply all the rows will be dealt with similar number, similar cells. So overall, the total number of the cells is going to be mn. In one row, you are having n cells, and in series combination, EMF of all the cells are added together with algebraic method. Then in one line, you are going to have total EMF of the cell, NE, total internal resistance would be added one by one, and we have the value NR. Now, NR in each row, NR, NR, NR. When equal resistances are connected in parallel n times, the resultant in parallel combination becomes 1 upon n of the single value. Here single value is NR. NR, NR, these are all connected m times. Then in that case, you are having total internal resistance NR upon M. We are using the same convention that in parallel combination, the whole value becomes 1 upon N. But here the number of rows is M, that's why it is NR by M. So the total resistance now becomes capital R is external resistance that has been connected over here, plus total internal resistance, and this finally amounts to MR plus NR upon M. This is the total resistance of the circuit. Total EMF, because in parallel combination, when the cells are identical in all branches, the EMF is never added. Total EMF is going to be NE, NE, NE so many times, but overall the resultant EMF is going to be NE itself. Now you have the total EMF, total resistance. That means the current you are going to have is total EMF divided by total resistance, and the value would be here MNE upon MR plus NR. You see, the current you are getting is this thing. In order to get the condition for maximum current, one has to differentiate. The only mathematical condition for getting maximum or minimum value is first differential should be 0. By doing all that, you are concerned with the result here. By doing the process of differentiation and all that, we get one very important condition, that for maximum current, the condition finally comes out to be this thing. You see, MR, NR, you might say R equal to NR upon M. This format becomes easier to remember, but overall, theoretically, you could remember this way: external resistance, and this is total internal resistance. That means you could say, in order to get the maximum current, the total internal resistance must be equal to external resistance. You put the value of this condition, you will find when MR is equal to NR, you will find here by putting both equal in this case, you will find the maximum value of current NE over 2R. You replace N by M, then we'll have to replace this capital R by small r. By putting this value, One extraordinary condition here, just because of coincidence, it becomes very peculiar that we get same condition for maximum power and also for the maximum current. This condition is for both. This is common condition. So when you are getting the maximum current in mix combination, it's obvious, it's compulsory that you are going to get maximum power as well. Maximum power, by putting this value, you will find values given here. You see, whenever you are given a particular number of cells, suppose 64, 256 cells, and you are given condition how to find the number of cells in one row, how to find the number of rows, for that you have to emphasize only one equation. First of all, that total number of cells is given by this relation. And then second condition applies, that in one row EMF could be increased. But by repeating the number of rows, you are not going to increase the EMF. So whatever maximum EMF is to be obtained, that should be decided in one row itself, because after that EMF will not increase by connecting them in parallel. Only keeping two things in mind, you can solve any complex problem in mixed combination.